Hi, I am Vítor, and thanks all for coming to this event. I'm going to present a modality-level explainable framework for misinformation checking in social network. This is a part of a work from my PhD studies, and it's co-authored by Professor Aline Paz from Federal Fluminense University. Well, let me first start with a question. Have you ever caught yourself scrolling down your feed from your favorite social networks and see that most information that found are news? That's quite common since from some studies, half of Americans, for example, follows news from social networks. And in Latin America, almost 2/3 of the requested people see news from social networks. So it's a pretty common thing nowadays. And social networks comes with a good side that can scale information and spread news, mostly time-critical news, such as hurricanes, for example. So people can share this information. It's very easy and gives agility and scalability to do so. But it's a two-edged knife, because at the same time you can fast spread information, good information, you can also spread bad information, which are fake news or misleading information that we call from now on misinformation. So it's important to mitigate this problem. Currently, there are some agencies that fact-checking these informations using human workforce. However, it's a huge problem since information spreads at a large scale and human workforce cannot scale as fast. So recent works are bringing new tools to help solve this problem. However, these new tools lack from important part, which is leveraged from multimodal aspects such as images. They usually only rely on text. And most important, those classifications, misinformation classifications, need to be explainable so humans can trust this information. So that's also a key fact that is missing in recent works. So our goal with this work is to present a new framework that we call a modality-level explainable framework to bring together modality, multimodality, and also explainable classification for fact-check, for misinformation checking. So our goal with this framework is to combine both interpretability and completeness to enhance overall explainability. So actually, we have to define what explainability is. It's not a common ground for everyone, and it's more a philosophical question from what explainable is than common sense knowledge. So our vision that from explainability is a two-dimensional concept. On the first dimension, we have interpretability and completeness, which interpretability is the ability to a human with its own bias, own knowledge, understand the explainability given. So it depends from user to user. And completeness, which is the in-depth explanations of the mathematical transforms within the network. And also, on the second dimension, we have the target that we're trying to explain. Sometimes we're trying to explain just the process from giving an input and having the output, or the representation itself, where we try to understand the waves that are given in our network. So our methodology, we start with formally defining our problem. So given a tweet node, we work on tweet on this work, which is a set that combines the tweet content itself, the textual content, the multimodal content of the tweet, the video, the images, Also, shallow metadata, we call shallow metadata in metadata that is given, such as the number of tweets, retweets, etc. And finally, the connections of these tweets, the K-hop connections such as retweets, replies, among others. And our goal is to classify the tweet as misinformation or fact and identify the most important features that led this classification. So our framework starts compressing the tweet node and encoding this information. So first, we encode the shallow metadata. Here we use the number of replies, number of quotes, and number of retweets. We just aggregate this information. And also encode the textual content of the tweet with a bird tweet. We then combine these two representation vectors to form a unique multimodal vector. And then we combine this with the K-hop information and classify with the assistance of a graph attention network. And then we have the classification of a misinformation or fact. Finally, we got this classification and submitted this same information, the same encoding vector, multimodal encoded vector, to a GraphLime where we extract the most important features. If the most important features rely on the text, we then further use Captain to identify the most important information within the text. To our experiments, we use MuMin with a new public misinformation graph dataset that contains multimodal information from Twitter. We filtered this dataset to use only, for now, English written tweets, 4 main entities, and 6 relationships. We then proceed to analyze our solution. We perform a quantitative analysis and a qualitative analysis, and our preliminary findings shows that on a quantitative aspect, that the multimodal feature vector does enhance overall results on classification. So we have a 5% difference between the text-based only feature vector with the multimodal features. And from a qualitative analysis, we saw 2 cases. In the first case, the GraphLime indicates the most important features were the retweet and reply. And then we proceed to check this information, and we saw that people who retweeted or replied this tweet tend to spread misinformation. On the second case, the GraphLime indicates the most important part of the feature were the text, and we then proceed, we use the Captain with the text, showing that key words from this text help, in fact, to identify a misinformation or a fact. In this case, a fact. So concluding, our frameworks achieves better performance using multimodal information, while the modality-level explainability does improve overall understanding towards the classification. We point as future works first to enhance our spectrum from multimodality, so leverage also images, videos, and all sorts of information on tweets to improve both interpretability and completeness. Then we want to try to leverage this framework to other languages, so change our language model, for example, to a multimodal language model, and then use Portuguese and Spanish and any other language. And finally, study this framework on subject-specific topics, such as COVID, elections, and not a broad sense that we do right now. So, thanks all.